The LI for this lesson is to be able to use calculus to solve problems involving maxima and minima. And so far in this chapter, we've seen how we can have displacement written as a function of time, or velocity as a function of time, or acceleration as a function of time. And in the last lesson, we also looked at how we get from the displacement as a function of time to velocity, and we said that we differentiate, get down, and then the velocity, if we want to know the acceleration, we need to differentiate the velocity, and we differentiate with respect to time. So today we're going to be using maxima and minima problems, and that means that we are going to be having a look at the maximum and minimum points on the graphs. So the example says a child is playing with the yo-yo leaves the child's hand at time is 0 and travels vertically in a straight line before returning to the child's hand. The distance of the yo-yo from the child's hand is given by and this equation here. And it's only between t being 0 and 3, so between 0 and 3 seconds, and we need to justify that restriction. Well, to justify that, we're just going to see what this graph looks like. So I've got that s is equal to 0.6t plus 0.4t squared minus 0.2t cubed. And it's a negative cubic graph, so I know that it's going to look something like this. Isn't very well drawn, but you get it. But I just don't know the roots yet. I don't know where the axes go on that. So let's have a look at trying to work out the roots of this equation. What I'm going to do is I'm going to take out a factor of minus 0.2t. And the reason I'm going to do this is I can see that 0.2 goes in all of these, so that makes it a bit nicer to take a factor of 0.2 out. Obviously t is in all of them, so I'm going to take t out to make it nicer. And then I've decided to take minus 0.2t just because I prefer the highest power to be positive. It's my preference, you don't have to do that, but that's what I prefer. So I've taken out minus 0.t. So here, if I divide 0.2, I get 3, and obviously the t's because I've taken that t factor out. Here, I'm going to have a minus, oh sorry, I should have had a minus 3 in there as well, actually, there's my trick, because I divided by minus 0.2. Again, here I'm going by minus 0.2, so I'm getting minus 2t. Sorry, I messed this. Then here, I'm going to get plus, because I'm dividing by minus 0.2, t squared. And I don't quite like the order that's in, so I'm going to write it in a different order. So I get s is minus 0.2t, open bracket, put the t squared first, t squared minus 2t minus 3. That's a lot nicer. Now I can probably factorise this nice and quickly. Two numbers that multiply to make minus 3, but add to make minus 2. Well, I'm going to get t minus 3 and t plus 1. So I factorise the whole thing now. I've got s is minus 0.2t, t minus 3 and t plus 1. And I can quickly see my roots. So one of the roots is going to be at t equals 0. One of them is going to be t equals 3. One of them is going to be at t equals minus 1. So if I get myself some axes there, here's t and here's s. I know I'm going to have a root at t is minus 1, a root at t is 0, and a root at t is 3. And we said the graph looks something like this, so it goes down and then up as it goes to the right. So it's going to be coming down here and then up, like so. And what we're talking about is we're saying that the distance of the yo-yo from the child's hand goes vertically up and then returns to the child's hand. So that's just looking at this section here. At t is 0, that's when it goes up, and it returns back to the child at t equals 3. And that's how we justify that restriction at 0, t is 3. If just explain that, so we say at here, t is 0, s equals 0, and at t equals 3, s equals 0, and between those 2 points, s is positive. So we'll say s is positive between t equals 0 and t equals 3. And s is a distance, so we are only looking at when it's positive. We're talking the distance, not the displacement here. Right, let's second bit then, because this is where we are using that maximum and minimum section. So it says, find the maximum distance of the yo-yo from the child's hand. Now I can see, because we're only focusing on this part of the graph between 0 and 3, the maximum distance is going to occur at this point here. However, my graph's a bit misleading. That looks like that's at t is 1.5. It's not necessarily the case. The graph could be going up and then slowly down. I don't know where that maximum point is occurring. So I'm going to differentiate to work out. So I've got that s is equal to 0.6t plus 0.4t squared minus 0.2t cubed. And to find the maximum point, we differentiate ds by dt. Here I'm going to get 0.6. Here I'm going to get plus 0.8t. And here I'm going to get minus 0.6t squared. And what can we do? We could multiply them by, what can I do? What's the best to do here? I could multiply them. So I know that the maximum point, is going to occur when that is equal to 0. Now I don't like having these points, 0.0.0 in there. So I'm going to multiply, I think I'll multiply by 5 would be my best thing to do. So I multiply them by 5. I'm going to get, that is 3 plus, this one is 4, minus 3t squared equals, and actually I'm also going to multiply them all by minus 1 now because I don't like having a negative in front of t squared, that's just me. So I get 3t squared minus 4t minus 3 is equal to 0. And you probably can't factorise this, it's a tricky one, so we're just going to use the quadratic formula. T equals minus b, which is 4, plus or minus the square root of b squared minus 4c. Now I actually have done this one, so I know what it's going to be. It's going to be 52 in there. But if you don't believe me, you can do the whole thing yourself. Divide by 6. And I get two different answers. I can get that t is going to be 1.8685 or minus 0.5351. Now, this is not going to be a solution because t can't be negative. So I'm just going to write not a solution. So instead, I know that this is the time that the maximum distance occurs. However, I've not completely finished because I actually want to find the maximum distance, not just the time that it occurs at. So I need to substitute that time there into my expression for s. So I'm saying, sorry to squeeze this on the bottom, s equals 0.6, and then instead of t, I'm using 1.8685. Obviously, if you carried on with your calculator, you could just use the add button to make this more accurate. Plus 0.4, 1.8685 squared, minus 0.2, 1.8685 cubed. And that gives me a maximum distance of 1.21 meters. Let's write that. So that is my maximum distance. I got that by differentiating and setting it equal to 0, working out the time that occurred, and then subbing it back in to find the maximum distance. So now that you've done the example, you should be able to have a go at exercise 11C.